Hello and welcome to BinarX Week 3. We're going to do a CubeSat mission case study. So this will be, I won't talk to you for very long, but it'll be a self-directed research activity within your payload groups or teams. So you can learn a little bit more about what payloads are and what's come in the past and give you some ideas to refine your current concepts. This little video from NASA is very short, just to recap on what is a CubeSat. So just watch that one. There's also a longer video if you go into the online resources that are on your handout sheets, and you can actually see our engineers from the Binar Space Program give a more in-depth explanation into CubeSats and payloads on the actual Binar platform. So remember, you're not building the CubeSat, you're building the payload to go inside our Binar CubeSats. And yep, what is a CubeSat? So there is on the left Binar 234 in 1U form factor, so all tied up and tucked in. And then on the right there is an image of Binar 2 and 3, 4 with the solar panels and the antenna deployed. So remember, those don't pop out straight away, but about a half an hour after deployment, once it's clear of the space station, those come out to give us our communications and our extra power budgets. So recapping, what is a payload? It's in a CubeSat, it's all the equipment and tools packed into the CubeSat that actually do the job. So the purpose of the payload, or the purpose of the satellite. So the payload in a satellite is the part of the satellite that gives it its primary function or purpose. So whether that's communications or technology demonstration or scientific, experiments or Earth observation, those are the missions that your payload is going to carry out. So today, you'll be working in your payload teams. Follow the instructions on the session outline, which your teacher should have a copy of for you if I'm not there in person to give it to you myself. And then follow those instructions, do some research on a past CubeSat mission and payload that interests you, and then fill out this summary sheet with your team name and your school. Now again, the team names can change to working title just so that we have a reference, and then hand those back to your teacher at the end of your session. And as you work through it, start thinking about how you might apply some of what you learned about past payloads to refining your own payload concepts. So that's actually it. We are at the end of term 1, so thank you everyone for your participation and your continued interest. We'll be picking back up after the Easter school break, learning about the space environment, so understanding what kind of environment your payload's going to be operating in. We'll also learn about LEO, which is the acronym for low Earth orbit, which is the orbit which your payload, our satellites and your payloads are going to most likely be deployed into in the future. All right, and if you have any questions, just flick them on through to BinarX at curtin.edu.au, and we'll see you in term 2. Thanks, everyone.